We're going to continue practicing factoring polynomials. If we take a look at number 1, we've got 4x squared plus 16x plus 15. Again, you're going to ask yourself, does it have a common factor? This does not. So then you ask yourself, well, what times what gives us the product of the leading coefficient times the constant? So what times what gives us 60? And what plus what gives us the coefficient of the linear term, 16? When we find the number pattern that works, we use those two values here and we rewrite the linear term. The numbers that we need would be 10 and 6. Once we have our 4 terms, we can look at it in pairs and divide out what they have in common. First pair we could divide out a 2x, the second pair we could divide out a 3. Here we're looking to see, are we multiplying by the same amount? And we are, 2x plus 5. So our factored form would be 2x plus 5 times 2x plus 3. Again, we look to see, does it have a greatest common factor to divide out? Here, we do not. Then we're going to take our leading coefficient times our constant. So what times what gives us a negative 270, and what plus what gives us a negative 3. When we find the number values that work, we're going to write our expression as 4 terms. The numbers we're going to use are a positive 15 and a negative 18. So then, grouping by pairs, the first pair we could divide out a 5x, the second pair we could divide out a negative 3. Here we see that each term is being multiplied by 2x plus 3, so our factors would be 2x plus 3 times 5x minus 9. Always look to see if you have a greatest common factor. Here, we can divide out 3 from each term. Therefore, we would be working with 2x squared plus x minus 3. We have a quadratic that we're working with, so again, check the leading coefficient times the constant. So what times what gives us negative 6, and what plus what gives us 1? If we can find a pair that works for both of those, we can write our quadratic as 4 terms. Here, we could use a positive 3 and a negative 2 to meet both of those requirements. As we look at pairs, the first pair here I could divide out an x. The second pair I can divide a negative 1. I can see both terms are being multiplied by 2x plus 3. So my factors are going to be 2 times 2x plus 3 times x minus 1. For our next polynomial, again, look to see if there's a greatest common factor we can divide out. Here we do not have one. So again, we're going to take the leading coefficient times the constant. What times what gives us 80? What plus what gives us 18? Once we think of the number pair, we can write our quadratic as 4 terms. Here, we could use an 8 and a 10. We're going to split it into pairs. So the first pair, we could divide out a 2x, and the second pair, we could divide out a 1. We can see that we're multiplying 8x plus 5 by 2x plus 1. Therefore, our factors would be 8x plus 5 and 2x plus 1. Continue to factor. Again, look to see if you have a greatest common factor you can divide out. We typically don't use negative leading coefficients for our quadratics, so I will divide out a negative 1. Now, working with what I have here, what times what gives me negative 28, what plus what gives me 3. The numbers I can use would be a 7 and a 4, as long as the 7 is positive. Again, breaking them into pairs, the first pair I can divide out an x, the second pair I can divide out a negative 4. I can see that x plus 7 is being multiplied by x and negative 4. So my factors are going to be negative 1 times x plus 7 times x minus 4. For our next polynomial, again, look to see if you have a greatest common factor you can divide out. Here, it looks like I could divide out a 2, and I'm also going to divide by a negative, so I no longer have a negative leading coefficient. So what I'm going to do is multiply my leading coefficient times my constant. What times what gives me negative 4, and what plus what gives me negative 3. So the numbers I can use would be a -4 and a +1. So again, looking at it in pairs, the first pair I could divide out a 2x, the second pair I could divide out a 1. I can see that I'm multiplying x minus 2 by 2x plus 1. Therefore, my factors would be -2x times x minus 2 times 2x plus 1. Here we have our polynomial, and again you look to see, does it have any greatest common factors? I also can see that it's missing the linear term, so I could rewrite it with the placeholder of 0x to help me think about my factoring process. So again, each of these terms is divisible by 3, so if I divide out my greatest common factor, I'm here. So with my quadratic, leading coefficient times the constant, what times what gives me -16, and what plus what equals 0? Finding a number pattern that works, I can write my quadratic with 4 terms. So that would be x squared plus 4x minus 16. First pair, I could divide out on x. Second pair, I could divide out a -4. So it looks like I have x plus 4 being multiplied by x and a -4. Therefore, my factored form would be 3 times x plus 4 times x minus 4. So here's my polynomial. Again, first thing to look for is, does it have any greatest common factors to divide out? And here I do not. But I have 4 terms, so I can look at them in pairs. The first pair I could divide out an x squared. The second pair I could divide a -5. So we can see that x plus 6 is being multiplied by x squared minus 5. I have a quadratic here, so again, we want to think about if we can factor that. And it's missing the linear term, so you can think of it as x squared plus 0x minus 5. So the pattern we have to think about is what times what gives us -5, and what plus what equals 0. Well, the only way I can multiply together to get 5 would be using a 5 and a 1, and I cannot add them to make a 0. So what I have above here is as completely factored as I can get the polynomial. So my factored form would be x plus 6 times x squared minus 5. Here we have our polynomial, and again you look to see, does it have a greatest common factor? It does not. So then we're going to take our leading coefficient times our constant. So we have to think, what times what equals -420, and what plus what equals -1? If I find a number pair that works for both of those rules, I'm going to take my quadratic and write it in 4 terms. I can use a -21 and a +20 to multiply to get -420 and add to get -1. So by looking in pairs, the first pair I can divide out a 3x. The second pair I could divide out a 5. I can see that 4x minus 7 is being multiplied by 3x and 5. So my factored form would be 4x minus 7 times 3x plus 5. At this point, you're to work on your Unit 6, Day 10 worksheet. This will be collected tomorrow.